Hello, and welcome to another edition of Mobile Sec Mondays. In this video, we're going to solve challenge 6 from the IG Learner series. So let's open it. So inside my Android x86 emulator, I'm going to click on the circle with the 6 dots, going to click on Learner, and it's going to open the app, and I'm going to make it bigger just to so I can work with it. Okay, lesson 6, encryption versus encryption. So let's click on it and see what it says. Okay. So we have a challenge phone number 890-423-1194. Let's look at the instructions. It says, this lesson logged out an authentication token that was created based on something stored locally, specifically your phone number and a static key. The goal is to figure out what encryption algorithm was used and locate the key, and then enter an authentication token for another number in the provided box. Hint, if decompiling and reversing doesn't help you figure out how to create the token, there are a few shortcuts. Okay, so let's remove this. It looks like we need to decompile the app. I guess, sorry I didn't mention before, if you need to install the IG Learner onto the Android x86 emulator, I have another video for installing apps onto the emulator. I'm not going to discuss that in this video. Look at a previous video that I've done, and that should give you the clue. So now we need to reverse engineer this challenge. So what do? Well, if you look on the left-hand side, I have Intro to Android Security, a virtual machine. Just to give a quick background, this is a virtual machine that I created. It was inspired by Android Tamer, and it has all of the common hacking tools for Android, specifically just for Android hacking. So if we go to Menu, Reverse Engineering, and then let's go to JADX GUI. And so what JADX is we can reverse engineer an Android app using this tool. And I'm doing the GUI because I like a graphical user interface. And so inside of the Intro to Android Security virtual machine, all of the insecure apps, I have insecure apps for you, the participant or learner, to play with and learn. So that is in the documents directory under Android documents. I'm already there. I'm going to click on IG Learner APK. I'm going to double click. And what JADX is going to do is it's going to pretty much reverse engineer the app. And we're seeing that here. So now what I'm going to do is I'm going to go to com intrepidusgroup.learner. And so maximizing this. So maximizing or expanding this, we see the different activities for that correspond to the different challenges inside IG Learner. So we're going to go to lesson 6 because that's the lesson we're working on. And I'm going to just make this a little bigger. And so now with reverse engineering the app, we are looking at the source code. And the source code in Android is written in Java. So we're actually looking at Java code. I'm going to make this a bit bigger so we can see it. So we have successfully reverse engineered the app. So, but now we have this phone number and we need to find the encryption algorithm used, and we need to find the token. Okay, so if we scroll down, again, we're looking for encryption and a token or a secret key. So scrolling down, we really don't see anything. Get phone number. So we already have our phone number here, 890-423-1194. So while this is interesting, we already have the phone number. So let's keep going. And, oh, wait, we see something here. Line 136, encrypt number with AES. AES is Advanced Encryption Standard. And this is an encryption algorithm. So remember, in the instructions, we needed to find the encryption algorithm and locate the key. So we found the encryption algorithm here, AES, Advanced Encryption Standard. And if we scroll down a couple lines on line 40, we see this Encrypted Learner 1. So I'm thinking that's the secret key, and it's hard-coded, which is a no-no. Again, I mentioned this in previous videos. You know, do not hard-code passwords, keys, or anything like that in Android apps, because as you can see, it is very easy to reverse engineer them. So we have an idea of what our encryption is, AES, or Advanced Encryption Standard, and we have our key here, Encrypted Learner 1. So let's go to the internet, because now we need to actually encrypt our encrypt with the phone number and this key and see what we get. So going online, I'm going to say AES encryption Android online. So we have this DevGLAN, which is an online tool for AES, and let's click that. And the text to be encrypted is going to be the phone number. So if we go here and we type the phone number, 890 423-1194. And the select mode, we're going to leave it to ECB. Key size, we're going to leave it to 128. For the secret key, we're going to do this Encrypted Learner 1. So if I go here, and I'm going to type Encrypt and Learner 1. And let me see if I type that correctly. INTRE Learner 1. Yes. Okay. Going back into our code, we see on line 149 base 64. So what we're going to do is we're going to get the encryption key, and then we're going to encode it to base 64. Base 64 is an encoding, right? Not secure at all. Encoding is not secure. But we're going to do the encoding. So if we go back to our AES encryption or decryption tool, we see the output format as base 64 or hex. We're going to keep it as base 64. So now we're going to say encrypt, and we have this value here. So if we go and if we type 8SJ5CU SF7 RHD Zora ZSTBG. Okay, if we say, if we say send string, we solved the challenge. Okay, so we solved it. So, what did we learn? A, it is very easy to reverse engineer Android apps. Most times when you reverse engineer, there's something called obfuscation, where the developer would try to not make the source code so easy. But even still, with Android apps, it is very easy to reverse engineer an app. It's trivial. Looking at the code, we found the encryption that was being used, which is AES. And then we found the key, which was hard-coded, again, which is a no-no. You don't hard-code keys, passwords, anything secret, you do not hard-code. So that is Encrypted Learner 1. And we see on line 149, we're actually doing the encoding, the encryption, and then we're going to encode it into base 64. And that's what we did here. We did the text format of base 64. So what this exercise is showing is that, well, I believe AES is no longer the standard. It's, hold on, wrong one, encryption. Yeah, advanced encryption standard, and I believe, yeah, AES 256 is the most secure. So if you look here, we're using 128. So that's not the most secure AES encryption. So essentially what this exercise is showing is that encoding is not encryption, right? Because we did two things here. We had encryption where we use AES and we brought in the phone number, which in our case was the 890-423-1194. And then the key, which was hard coded. Again, no, you don't hard code your key. But in this case, it was. And then we did all the steps to do AES encryption, right? And then at the end, it was, oh yeah, let's encode it using base 64. So whoever developed this challenge, they're probably thinking, whoever is looking at this code, will not be able to find, the correct token because, I'm doing the encryption, but I'm doing encoding, base 64 encoding on top of it. So that was supposed to be to throw you off or throw us off, but it didn't, right? Because we solved the challenge. So just to go, because I want to do a little bit on AES, what is ECB? So ECB is electronic code book. And so let's see, I'm going to go to Wikipedia, don't judge me. So let's see. Okay, so ECB is the simplest of the encryption modes, electronic code book, named after conventional physical code books. The message is divided into blocks, and each block is encrypted separately. So this is an example. We have the key, and in this case, the key is Encrypted Learner 1. The plain text, again, is the phone number that we had, and, putting that in, those two values in, putting it into the cipher encryption of AES, we get the cipher text or the text that was encrypted. And so this is an example of ECB, but it says the disadvantage of this method is a lack of diffusion. ECB encrypts identical plain text blocks into identical cipher text blocks. So it's not good for hiding data patterns. So meaning if I have particular words, those blocks are going to be the same. So it's saying ECB is not recommended for use in cryptographic protocols, right? So again, this is very weak. So inside of our code here for the challenge, this challenge uses the weakest form of AES. First, we're using 128. The strongest is 256. And we're using ECB mode, electronic codebook mode, which is not the most secure, because if we have different words that are the same, the blocks would be the same, right? And then you can start to use that to start figuring out words and patterns, to get back to the original code. So again, what we learned in this challenge: encryption is not encoding. They're not one and the same, right? Encryption, you take encryption, you have plain text, you have a key or a cipher, and then you get I misspoke. You have plain text and you have a key. You put that together in the algorithm, you get ciphertext. Ciphertext is the actual encryption, the encrypted code. And the reason why you want to do encrypted code is, remember, we were encrypting a phone number, 890-423-1194, right? And we had a key of Encrypted Learner 1. But notice when we executed the algorithm, we had this output that to the naked eye will look like gibberish, right? And that's what you want with encryption. So cryptography, which is the superset of everything, or the overarching, cryptography is the method of sending secure messages through an insecure channel, right? So you use cryptography every day when you're on the internet, right? And you're, for instance, if you're checking your banking app or your email or anything that is sensitive, you're using cryptography because you're sending information back and forth through an insecure channel, the internet. The internet is not secure at all, right? It is severely insecure. So what you would do to counteract that is to use cryptography and, encryption and decryption and tokens, and send that back and forth. Well, that's possibly one way you could do it. Encrypt and decrypt to send information back and forth over the internet. So again, cryptography is the process of sending secure messages through an insecure channel. That's how you should think of cryptography. So in this instance, we only use one half of cryptography, and that's actually encrypting. So then there's actually second half of that, which is decryption. So as the name, or as it sounds like, it's the reverse of what we've done. So we have this gibberish, and now we want to get back to our original message. Now this was not part of the exercise, but I do want to show you an example of that. So let's just say we're going to use our AES encrypted output, and we're going to enter our secret key, Encrypted Learner 1, and we're going to decrypt. So now we actually have, that was the base 64, and we decrypted or decoded to plain text, because remember this was in base 64. And what do you know? What do we have? Our phone number, 890-423-1194. 890-423-1194. So encryption is the process of sending your plain text, in this case 890-423-1194, and you put it in gibberish to the naked eye, which is this 8SJ5 da 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 da. And then the decryption is taking the 8SJ5 da 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 da, and then doing the reverse of that to get the original message. In this case, the original message is 890-423-1194, which is correct because we did it on the left-hand side with what needs to be encrypted. And again, like I said, you use this every day. You use cryptography every day, and you probably don't even realize it. If you're sending information, back and forth, you're using cryptography. You have used cryptography, like I said, every day, but you probably don't even know. AES is one of the encryption standards, and again, the algorithm to do that is outside of this video. Cryptography in itself is a whole field, with crypto analysts and very skilled people, high level people in mathematics, because you use a lot of math, prime numbers, numbers that are not divisible except for the number and the number itself in one. But one is divisible pretty much by everything except 0. Anyway, I have a minor in math. I'm not even going to go down that road. But yeah, so again, that's something that's totally outside the scope of this video. But I just wanted to show the complete picture of encrypting, which is taking our message and turning it into gibberish, and then taking the gibberish and then decrypting it to get our original message. And again, cryptography is the process of sending secure messages through an insecure channel. And most times, the easy way to think of that is sending messages through the internet. The internet is highly insecure. So I hope you learned a lot in this video, and I can't wait to see you in our next installment of Mobile Sec Mondays. Have a good day. Bye.